Welcome to Sundar's lecture. This is lecture number 20, and in this lecture, we are going to see a new topic, right? A new topic. So, in the last lectures, we would have seen supernode problems using in nodal voltage analysis using matrix method, and we would have tried to solve this problem by matrix method, and we have found all the answers, right? You see, we have found all the answers. What is VAO, what is VBO, and what is VCO? All these things we have seen in the previous lecture, and I have told you, please go through my lecture number 13, and so that you can easily find what is the current in each resistor with the help of VAO, VBO, and VCO by voltage between any two points. That is what we have seen, right? Now, in this lecture, the topic is circuits with dependent sources. So we have not used the name independent sources in any of our lectures, since you can see that this is voltage source. We know that this is a voltage source. These two, like that, we would have displayed voltage sources in our circuits like this. This may be a battery, or this may be source somewhere from the generator, or something else. These two are voltage sources, and current sources we would have used like this, right? So what is these kind of sources tells us that, see, I will write here, see, these kind of sources never depend on any other parameters in the circuit, which means if you say V is equal to 10 volt, like this, for example, I am saying this V is equal to 10 volt, this V will be always 10 volt. It won't, or it does not depend on any other parameter in the circuit. It remains 10 volt throughout all the process. So this is fixed value, which means this will fix as 10 volt. And you see, if this is 2 ampere source, 2 ampere, which means I am saying that I is equal to 2 amperes, like this, um, in this source, then this 2 amp source will be constant throughout all the process. This 2 amps does not depend on any other parameter in the circuit. But what dependent sources will do, that we need to see now. So dependent sources, I am telling this by words, dependent sources will depend on the parameters that is existing in the circuit. Parameters or any other devices in the circuit, right? So here you see we have voltage sources, voltage sources. See, I am writing it in dependent sources. Under dependent sources, I am writing it as voltage sources. So voltage sources. So you see, these are all the symbols for independent sources. If you see like this, a symbol like this, then this displays us that this is a fixed voltage, which means it is independent sources, right? Then if you see like this, see, I will draw like this. Anyhow, this is the symbol of dependent sources, right? So you see, this is a plus voltage source, right? So this is plus, this is minus, and what we will do, this is nothing but Ki. I will write like this. What is this K? This K will be a constant, not 5 or 2 or anything it may be. But what is this I? See, this I, which is nothing but the current in any other branches in the circuit, right? That is nothing but this I. So these type of sources will be known as current dependent voltage sources. Current dependent, 1 minute, current dependent, 1 minute, current dependent voltage sources, right? What is the next one? What is the next one? So next one, you see the diagram will be like the same. If you see a diamond shaped so, symbols like this, then obviously these type of sources are called as dependent sources. Anything, it may be a voltage dependent source or it may be a current dependent source. Obviously, if you see any plus minus like this, then obviously this will be voltage source, right? But this is current dependent voltage source. Now I will write like this. See, what is this? Plus minus. So this is a voltage source, dependent voltage source. But what I will write, this is KV. KV. What is this K? K will be constant, 2, 3, 5, anything it may be. But what is this volt? V. This V, which is nothing but this voltage, is some other parameters or some other branch voltage, that if that voltage changes, then obviously this source voltage will also change. So I will explain you, but this is a general topic. Now I am telling you in general what does these kind of dependent sources will do. But while seeing in the problem, you it will be very easy to understand. Fine. Now, so what is these type of sources? Dependent sources are, this is voltage dependent voltage source. Voltage dependent voltage source. That's all, right? So next is, since all other things are current sources, only two dependent sources are available. That dependent sources, which is nothing but current dependent voltage source and voltage dependent voltage source. Next thing, it is a current sources. So current source, obviously you see, this is also displayed like this. No change. The symbol will be like this. Instead of plus minus, you will have like this symbol. Current direction, that will be given, right? So what is this? See, I will write Ki. Ki. This K, which is nothing but it is a constant. But this I, what is this I? This I will be some other branch current. Anyhow, see, this will be known as current dependent current sources. Current dependent current sources, right? Like this. So now next one, that is also current source. Anyhow, next one, current sources. This direction may be upward or downward, that it may differ. That is not an issue. Anyhow, this will be known as KV. What is this V? This V will be some other branch voltage, some other parameter or device voltages, that will be displayed like this. So what is this? Voltage dependent current sources. Voltage dependent current sources. So now you see, there are four different dependent sources are available, and all the symbols will be diamond shaped. Two voltage sources are available. One is current dependent voltage source, one is voltage dependent voltage source, and another one is current sources. In current sources, we have two different types. One is current dependent current sources, another one is voltage dependent current sources, right? So these are all the different types of dependent voltage dependent sources, right? With the help of this knowledge, we try to solve one problem so that we will get an idea, right? So we will do that now. For that, we will take a new page. See, this is the example problem. See, what is this voltage source? This voltage source, which is nothing but what is this? This is dependent voltage source. Sorry, independent voltage source that we have seen already. But you see this one, this is dependent source. What is this source? This is current dependent voltage source. See, this depends on some other current. What is this current? This I1, which is nothing but it is this current, this branch or this resistor's current or this loop current that we know, we have already seen, right? So if you want to solve these kind of problems, then obviously you have to write KVL expressions. It is KVL expressions, or you need to write the nodal voltage analysis or mesh current analysis method. Anyhow, whatever method you use, you cannot use the matrix method, right? That is the one thing you have to understand. Anyhow, we try to write down the expressions. Now we will take the mesh current analysis method by using KVL, right? So if you want to write, so you see they have already given this is I1, this is I2, right? So obviously what? This is I1 that is already given and this is I2. We know that. Then if you want to write the KVL expressions, then obviously what you need to do, you need to write the current directions in all resistors. This current directions is already given. Then what? This I1 will come here, right? And this I2 will come here. So this will be I2, right? So what we need to do, this is loop, there are two loops, this is first loop and this is second loop. We need to write two KVL expressions, right? So if you want to write, if you write two KVL expressions, then you see I will write for this loop first. So from here I will start. So in the current direction is like this. So I have to go from minus to plus. So plus 10 volt. Then I am going in the same direction as I1. So what I have to do, I have to put minus 4 into I1. Then I will come like this here and I come like this. You see I am going in the same direction as I1. So 6 minus 6 into I1, and I am coming in this direction. You see I2 is coming opposite to me. So obviously what I have to do, I have to put plus 6 I2. Then that's all. There is no any other elements present in this loop. So this is the first one. So if I simplify this, what I will get, I will bring all the parameters to the other side. So these two are okay. I will simplify this. 10 I1 minus 6 I2 will be equal to 10. This is the expression number 1. So that we know, right? So next one, I will write the KVL expression for this loop. So if I write the KVL expression for this loop, I will start here. So this will be minus, since I have to travel in this direction. See, this current is same as the direction traveled by us. So minus 6 I2, then this will be opposite to me. So plus 6 I1. Then you see I have to travel like this. This is a voltage source. Try to understand very clearly here. This is the voltage source, right? So if it is the voltage source, then I am traveling from plus to minus. Since my current direction is like this, so I am traveling from plus to minus. Then I have to put minus. What is the voltage value here? Voltage value is 2I1. So voltage value is 2I1. So that you have to write like this, right? So then this I2 and this resistor will also get what? This is nothing but I2, right? So this will be like this. So I'm traveling like this. So I'm coming in the same direction as I2. So what I have to do? I have to put minus my 2 into I2. That's all. No any other parameters or components available. So that should be equal to 0. So if I simplify this, so I am getting, if I simplify this, I will get this expression. Now what you do, you try to simplify these two expressions. If you simplify these two expressions, so you have two unknowns, so we will get I1 and I2. If I simplify this, so if I simplify this, I am getting I1 is equal to 1.43 and I2 is equal to 0.714 amperes. Now you can also find what is the voltage value of this dependent source. What is the voltage value? See, dependent source, that means current. So current dependent voltage source, what is the value? 2 into I1. So 2 into 1 point. So this will be 2I1, that is the value given. So what we can do, this we can substitute, right? What is I1? This will be 1.41. So we can easily substitute, that is, this is 1.43. so what is the value? Final value will be that is nothing but it will be equal to 2.86 volt. So this voltage source, what is the value? 2.86 volt. See, we can get a clear idea now. See, this voltage source, this depends on what is the current flows in this branch. Try to understand. Whatever the current that is flowing in 4 ohms resistor will change the value of voltage in this source. So that we are calling these type of sources as dependent sources. If this current value changes, for example, if I change this resistor 4 ohms to 8 ohms in the same circuit, then obviously this current I1 will change. If this current I1 changes, then obviously what will happen to this dependent voltage source? Also, this value will change. See, we are getting an idea now, right? So, independent sources, that this value will be 10 unless whatever the resistors are connected in the circuit values changes. But these dependent sources will always change. It depends on some other branch current or voltage. This is actually a voltage source, but that depends on some other branch current. So current dependent to voltage source. So these type of problems will give you a better insight or better understanding, right? So these type of problems will be asked in gate questions. Right? We try to solve many more problems in this dependent sources, because if you see any gate questions, all the gate questions are coming under this dependent sources. So we try to solve numerous problems, maybe 4 or 5 problems in this particular topic. Then we will go to the next topic. Fine, you go through this, you will get an idea. This is also very simple. Since we have already know what is mesh current analysis method, what is nodal voltage analysis method, now we can easily apply here. Whatever the method we know or whatever the circuit we have, we try to understand the circuit and we try to make a decision which method will give less time to solve this circuit. So we are under that section now, because we know we have solved many problems using mesh current and nodal voltage analysis method. Right? We will go through and we will see some other problems in the next class. Thank you. Have a nice day.